Class, today's lesson, right, I'll be making use of this time to go through the workbook with you. So on my screen here, you can see the answer to page 29 of your workbook A. Right, so workbook A, turn to page 29. So this is actually a table that compare the properties of elements, compounds, and mixtures. So we have learned so much about them during the last few practicals. So the question asks, are the components chemically combined? So you can see that elements is no, because it's by its own. Compound is yes, and mixture is no. And what are the properties? The second column. The second column, you can see the element has its properties of either metals or non-metals. Compound will have a unique properties, different from the elements is made up of unique properties on its own. Mixture will have some of it lah. For example, if I have a mixture iron and sulfur, the mixture that I got right will have some of the iron, some of the sulfur properties. So this is what we meant by mixture. Then the third column talks about, can it be broken down by chemical methods or by physical method? How do I separate them? Okay, for element, right, no matter what you do, cannot be broken down already. It's by its own itself. You cannot do anything to further break it down. But for compound, right, yes, compound, right, you can break down unless you use complicated method, chemical method. For example, water, H2O. In fact, right, if you apply electricity, you can separate water into hydrogen gas and oxygen gas. Okay, but it's a very, very complicated method, very expensive method. And then for mixture, right, you can easily separate it by physical method. For example, the last practical we have a mixture of salt and water, okay, or we have a mixture of sand and water. We can separate sand from water using filter paper, using filtration. I can separate my sand with water. Same thing as spaghetti and water. I can separate the two of them easily using the strainer. So this is actually the thing about mixture that you can easily separate it by physical method. So how about the components? Are they fixed proportion? Okay, element is actually no. Okay, sometimes the elements are like iron, copper and all that, right? They don't have really a fixed proportion. Okay, sometimes I have more iron, sometimes I have more carbon found naturally on Earth. But compound, yes, I told you before. In order to make water, I must have hydrogen two. I must have one oxygen. So two hydrogen and one oxygen give me H2O. So it's a fixed formula. And mixture, no. For example, today I'm very happy I add more salt with water. Tomorrow I don't have enough salt, so I have less salt and water. But I'm still able to make salt and water mixture. Okay, so much about question one. Okay, question two is about solubility. Okay, and rate of dissolving. So what are the factors affecting solubility? Temperature, okay, obviously. Okay, nature of solvent itself. Sometimes alcohol can dissolve better or water can dissolve better. Nature of solute. In this case, for example, salt and water, right? Sometimes salt can dissolve better in water. Salt cannot dissolve so much better in oil. So it actually depends on the nature of the solute or the nature of solvent that affect the solubility, whether it can dissolve or cannot dissolve. Then rate of dissolving, how much can I dissolve? That means rate of dissolving, I'm already assuming that is that the thing can dissolve. Okay, so it really depends on the size of solute particles. Like Milo, if I want to make Milo particles easily, right, my Milo particle must be as fine as possible. That's why when I stir, right, the Milo particles can dissolve quickly. And the rate of stirring as well. If I stir quickly, obviously my Milo particles can dissolve faster. Okay, so much about question one and two.